Alpha Centauri is the closest star system to our Sun, our next-door neighbor in the Milky Way. It's not just one star but three: Alpha Centauri A, Alpha Centauri B, and the red dwarf Proxima Centauri, which is actually the closest star to us. In 2016, astronomers discovered Proxima B, a rocky planet in the habitable zone around Proxima Centauri. Suddenly, Alpha Centauri became more than a distant point of light. It became a place that might harbor life. Why are we so fascinated by it? Because we're explorers at heart. Alpha Centauri is the nearest shore in the cosmic ocean, a destination we can actually point to in the night sky. The discovery of Proxima B turned our dreams into a real scientific quest. Could there be oceans or an atmosphere? Could life exist there? These questions drive our curiosity and fuel our desire to reach out. Going to Alpha Centauri isn't about planting a flag, it's about understanding our place in the universe. This system is a symbol of humanity's future, a source of wonder, and the first step in our interstellar story. When you look up, you're not just seeing distant stars, you're seeing potential destinations. Alpha Centauri is the logical first chapter in our journey across the galaxy. The pull of this nearby system is a cosmic siren song, calling us to explore. It's a challenge we were born to accept. Alpha Centauri is close, by cosmic standards. It's 4.37 light-years away. That's nearly 40 trillion kilometers. To put it in perspective, if the Sun were a grapefruit in London, Alpha Centauri would be another grapefruit in New York. The space between stars is a vast empty void. This is the tyranny of distance, the biggest barrier to interstellar travel. Even at light speed, the trip would take over 4 years, one way, but nothing with mass can reach light speed, and our fastest spacecraft would take tens of thousands of years. The scale of the journey redefines the problem entirely. We haven't even left the driveway, cosmically speaking. The challenge isn't just speed, it's rethinking travel itself. We need breakthroughs in propulsion and a new way to approach time and distance. The distance to Alpha Centauri is a wall that stood for all of human history, but humans are good at breaking down walls. With the right tools and ideas, we can take the first step. The journey of 4 light-years requires a giant leap, and we're just getting started. Our current space tech is impressive. We've sent probes past Pluto and into interstellar space. Voyager 1, our farthest spacecraft, is moving at 17 kilometers per second. At that speed, it would take 75,000 years to reach Alpha Centauri. Chemical rockets, our main propulsion method, are powerful but limited. The more fuel you carry, the heavier you get, and the more fuel you need. A vicious cycle. Even the Parker Solar Probe, our fastest spacecraft, would take over 6,000 years to get there. We've mastered interplanetary travel, but interstellar distances are a different league. The leap from planets to stars is as big as the leap from walking to flying. We need a new kind of engine, something beyond chemical rockets. Our current speed limit is a wall we can't break with today's technology. To reach the stars, we need a paradigm shift in propulsion. The next step isn't just faster rockets, it's a revolution in how we travel. The cosmos demands it, and we're searching for that breakthrough. If chemical rockets can't get us to Alpha Centauri in a lifetime, what can? Nuclear propulsion is one idea, using atomic energy for more efficient thrust. Project Orion even proposed using nuclear explosions to push a spacecraft forward. But to go really fast, we might need to leave fuel behind entirely. Enter light sails, giant ultra-thin mirrors pushed by powerful lasers from Earth. Photons have no mass, but their momentum can accelerate a sail to incredible speeds. Breakthrough Starshot plans to send tiny probes attached to light sails, accelerated to 20% the speed of light. At that speed, the journey would take just over 20 years. These probes could fly through the Alpha Centauri system, sending back data and images. For human travel, there's the concept of a generation ship, a self-sustaining world where generations live and die en route. The original crew would never see Alpha Centauri, their descendants would. It's a slow, patient approach, but it makes the journey possible. Whether by light sail or generation ship, we're reimagining how to cross the stars. The future of interstellar travel will demand bold, unconventional thinking, and the first real steps are already being planned. Reaching the stars isn't just an engineering challenge, it's a human one. Space is hostile. Radiation, zero gravity, and isolation threaten our bodies and minds. Without Earth's protection, cosmic rays can damage DNA and increase cancer risk. Long journeys mean decades or centuries in space, with health and psychological hurdles. Zero gravity weakens bones and muscles. Astronauts on the ISS exercise daily just to cope. The psychological toll of isolation and confinement is immense. To survive, we'll need ships that simulate gravity, perhaps by spinning, and recycle air, water, and waste perfectly. These ships must be self-sustaining biospheres, tiny Earths in the void. Crew selection and social dynamics will be as critical as engineering. The human factor may be the hardest part to solve. We must master psychology and biology, not just physics. Before we become an interstellar species, we must learn to carry our humanity with us. The stars demand nothing less. Science fiction has always led the way, inspiring real science to follow. Star Trek's warp drive, based on the theoretical Alcubierre drive, imagines bending spacetime to travel faster than light. It would require exotic matter we can't yet create, but it's not impossible. Hyperspace jumps in Star Wars capture our desire to bypass distance, even if there's no science behind them, yet. Sci-fi pushes us to ask, what if? And sometimes sparks real breakthroughs. Generation ships and cryosleep, staples of fiction, force us to confront the social and biological realities of long journeys. Cryosleep could solve boredom and aging, but the technology is far off. Light sails, once the stuff of Arthur C. Clarke's stories, are now being developed for real. Fiction gives us dreams, science gives us the tools to chase them. The interplay between imagination and reality is crucial. Every real project starts as a dream. The journey to Alpha Centauri will be built with both metal and imagination. Our future among the stars begins in the stories we tell. Why go to Alpha Centauri when Earth has so many problems? Because exploration is fundamental to being human. It's the same drive that led us across continents and oceans. The quest for Alpha Centauri will drive innovation, new propulsion, life support, AI, and energy tech that could transform life on Earth. The Apollo program gave us everything from GPS to medical imaging. Interstellar travel could spark even greater revolutions. There's also a survival imperative. Earth is fragile, and spreading to other worlds is the ultimate insurance policy. Establishing a foothold in another star system secures our long-term future. The journey gives us perspective, reminding us of our place in the cosmos and inspiring unity. Reaching for the stars unites us in a common goal. It's a grand adventure that brings out our best qualities: courage, ingenuity, and hope. The quest isn't just about travel, it's about who we are. The stars call to us, and we're compelled to answer. That's why we bother. Can humans ever reach Alpha Centauri? Yes, eventually. The laws of physics don't forbid it. The challenges are engineering, not fundamental. We went from the Wright brothers to the moon in 66 years. Progress is accelerating. The first missions will likely be robotic, like Breakthrough Starshot's tiny, fast probes. These scouts will map planets, analyze atmospheres, and search for life. Their discoveries will ignite public imagination and political will for human missions. After robotic pioneers, larger probes and advanced propulsion will follow. Only then will we plan for human journeys. Maybe fast ships, maybe generation ships. The method is uncertain, but the destination is clear. The dream of Alpha Centauri is a cathedral for humanity, built over generations. Every discovery and inspired mind is a step on that journey. One day our descendants may look up at two suns and know the journey was worth it. The stars are calling, and sooner or later, humanity will answer.